number of students, so F will represent the students who will play football and B will represent the basketball, and whereas I is an indoor game. Number of people will take both tea and milk is 35. Already 20 is common. 35 minus 20 is equal to 15. So how many students are there? Given N of U is equal to 85. That means number of students who will take a test in English and Hindi. E union H is equal to 85. This is the first condition given. Hello dear students, welcome to this session of basic mathematics class. I am Mr. Niranjan, faculty department of mathematics, Vidhyaashram PU College, the temple of excellence. Today in this session I am going to take very important concept, that is the problems based on the application of sets. Now in the previous class we have discussed some problems on applications of sets. The same thing I am going to take today. Now let us go to the list of formulas that we are going to use for today's problem. Suppose if A and B are any two finite sets, then N of A union B is equal to N of A plus N of B minus N of A intersection B. So if A and B are disjoint sets, that A intersection B is equal to null set, then N of A union B is equal to 0. If this becomes 0, then N of A union B is equal to N of A plus N of B for disjoint sets. So for any two finite sets A and B, N of A union B is equal to N of A plus N of B minus N of A intersection B. If A and B are any two disjoint sets, that means A intersection B is equal to a null set. If N of A intersection B is a null set, then A intersection B is a null set, then the number of elements in A intersection B is 0. If this becomes 0, then N of A union B is equal to N of A plus N of B. Similarly, if A, B, C are any three finite sets, then N of A union B union C is equal to N of A plus N of B plus N of C plus N of A intersection B intersection C minus N of A intersection B minus N of B intersection C and N of A intersection C. So these are the few formulas which we are going to use to solve the problems on applications on sets. Now suppose if A and A dash both are finite set, if A and A dash is the complement of A, are both finite sets, then N of A dash, number of elements in A dash is equal to N of U minus N of A. Number of elements in U minus number of elements in A, where U is the universal set. So N of A dash, the complement of A is, number of elements in the complement of A is N of U minus N of A, where U is the number of elements, N of U is number of elements in the universal set and N of A is the number of elements in the finite set A. If A and B are two finite sets, then N of A minus B is equal to N of A minus N of A intersection B. Similarly, number of elements in B minus A, the difference is B minus A is equal to N of B minus N of A intersection B. Okay, based on this, let us take few examples. Now let us come to the first problem. In a class of 100 students, 35 play football, 45 play basketball and 35 play indoor games. 10 play football and basketball, 10 will play both football and basketball, and 15 play basketball and indoor games both, and 5 play football, basketball and indoor games. So 5 play football, basketball and indoor games. If 15 do not play any game, then find how many play football and indoor games. This is the problem, very important problem. So in a class of 100 students, 35 play football, 45 play basketball and 35 play indoor games. Let us write first N of U. Number of students are 100. So what is given? N of U is equal to 100. Let us represent the student who play football as F. N of F is equal to 35. The number of students who play football is 35. And 45 play basketball. Let us represent as N of B. The number of students who play basketball is 45. And 35 play indoor games. So N of I is equal to 35. Okay. So here number of students in a school of 100 students, 35 play only football and 45 students will play basketball and 35 students will participate in indoor games. So this is the condition given. Further, 15 play basketball and indoor games both. That is nothing but the intersection. Okay, let us come to the next. 15 play basketball and indoor game. So 15 play, that is number of students who play basketball intersection indoor game. Basketball and indoor games as 15. So intersection of B and I is 15. Further, what is given? 5 play football, basketball, yes. Then 10 play both football and basketball. Number of students who play football and basketball is equal to 10. Right. Then 15 play, that is already written. 5 play football, basketball and indoor games. So all common. Number of students who play basketball, football and indoor games is equal to 5. Right. Then here what is given? 15 do not play any game in the sense, 15 do not play any game in the sense n of, that is, what is this? F union B union I is equal to, out of this total 100 students, 15 will not play. That means that's equal to 85. So let us subtract 15 from this total number of students. That will give number of students who will play football, basketball and indoor games. Now by this, what is required to find is, find how many play football and indoor games. So therefore n of how many play football F and indoor game intersection I, this is to be determined. What is to be determined is F intersection I, that's it. Okay. Now these are the given condition. Now from this formula, let us come to this formula. Using this formula, n of A union B union C is equal to n of A plus n of B plus n of C plus n of this, etc. Now using this formula, we can find out the solution for this. So therefore write down n of F union B union I is equal to n of F plus n of B plus n of I plus n of F intersection B intersection I minus n of F plus n of B plus n of I plus n of F intersection B intersection I minus n of F intersection B minus n of B intersection I minus n of F intersection I. This is. Now substitute what are the values we know. N of F union I is 85, that is 85 is equal to n of F. Number of students who play football is 35, 45 and 30. 35, 45, 35, 45 plus 35 plus n of F intersection. So they do not play. Intersection is, what is the total? N of, yes, 5 plus 5 minus F intersection B is, F intersection B is 10, F intersection B is 10 minus B intersection I is 15 minus F intersection. So F intersection I, this is to be determined. That's it. Simplify this, it will give the answer. See, very simple. We know that n of F union B union I is equal to n of F plus n of B plus n of I plus n of F intersection B intersection I minus n of F intersection B minus n of B intersection I minus n of F intersection I. Substitute these values. 85 is equal to 35 plus 45 plus 35 plus 5 minus 10 minus 15 minus, which is required to find is n of F intersection I. So what is this equal to? 85 is equal to, this is, see, 45 plus 35 is 80, 80 plus 40 is 120, 120 minus 25 minus n of F intersection I. So this is 85 is equal to 120 minus 25 is 95 minus n of F intersection I. Transfer this. So therefore n of F intersection I is equal to 95 minus 85, that is equal to 10. So therefore n of F intersection I is equal to 10. So the number of students who play football and indoor game is 10. 10 number of students will play both football as well as the indoor game. That's it. This is how we are going to solve this problem. Okay. Hope you followed. Right. Now this can be easily represented in a Venn diagram. So number of students, how many number of students are 100? Here 100 students are there. So number of students, so F will represent the students who will play football. and B will represent the basketball, and whereas I is an indoor game. Now let us write the first common. So the number of students who play all the games, that is basketball, football as indoor game is 5. So let us represent this as, this is the student who play football, basketball and indoor is 5. This is 5. Okay, then the number of students who will play basketball and indoor game, B intersection I. The number of students who play B and I, the intersection of these two. So that is nothing but 15 students. So 15 students, this is 15, already we have 5 here. 15 minus 5 is 10 students. So 10 plus 5 is 15. Similarly, let us come to B intersection F, the number of students who play football and basketball, F intersection B is 15. So F intersection B is 10. So F and B intersection is this. Already we have 5. 10 minus 5 is 5. So 5 plus 5 is 10. So intersection of F and B is 5 plus 5 is 10. Next, let us come to the number of students who play football then. So the total number of students are 35. So number of students who play football is 35. So already we have 5 plus 5 plus 5, 15. 35 minus 15 is equal to 20. This 20. Similarly, number of students who play basketball. How many students will play basketball? 45 students. So 45, in 45, already we have this common, that is 10 plus 5, 15 plus 5, 20. So 45 minus 20, that's equal to 25 here. Similarly, the number of students who participated in indoor games is 35. So that is I. So 35 students minus, already we have 10 plus 5 plus 5, that is 10, 15, 20. 20, that's equal to 15. So this is 15. Right. So if you add this, then definitely you will get the number of students who participated in football and the indoor game. Football and the indoor game is F intersection is equal to I. That's it. So that is nothing but the solution for this equation. This is how we are going to represent in a Venn diagram. Okay. Now let us come to the next problem. Now the next problem is, out of 250 people, 160 drink coffee, 90 drink tea, 85 drink milk, 45 drink coffee and tea, 35 drink tea and milk, 20 drink all the three. How many will drink coffee and milk? Same as that of the previous problem. Now let us write down what is given here. Given that, now out of 250, number of people's N of U is 250. 160 drink coffee. So N of C is equal to 160. Number of people who drink coffee is 160. 90 drink tea. N of T, number of people who drink tea is 90. 85 drink milk. So number of person who takes milk is 85. So in a group of 250 people, so number of people who take coffee is 160, number of people who will take tea is 90, and the number of people who will take milk is 85. Now 45 drink coffee and tea. So number of people who take coffee intersection tea, NC intersection T is 45. So the 45 drink coffee and tea. 35 drink tea and milk. So number of people who take tea intersection milk is equal to, how many people will take? 35. 20 will take all the three drinks, that is, therefore N of all means, so coffee intersection tea intersection milk. So the number of people will take coffee, tea and milk will be 20. Now then how many will drink coffee and tea? So therefore what is to find is, how many of will drink coffee intersection milk. This is to be determined. N of C intersection F. That's it. See, these are the given conditions. N of U is nothing but the number of people who will take coffee, then tea, then milk is denoted as N of C union T union M. So N of U is nothing but 250. N of C is 160, N of T is 90, N of M is 85. Number of people who will take coffee and tea is 45. Number of people who will take tea and milk is 35. Number of people who will take all coffee, tea and milk is 20. And what is required to find is number of people who will take only coffee and milk. C intersection M. Same as that of the previous problem. So what is the formula we are going to use? N of A union B union C is equal to N of A plus N of B plus N of C. Right. Okay. I'll go to the next page. Therefore, N of, I'll take C union T union M is equal to N of C plus N of T plus N of M plus N of C intersection T intersection M minus N of C intersection T minus N of T intersection M, N of T intersection M minus N of, last one is C intersection M. This is the formula. Now substitute the values. C union T union M is 250, that is already given. 250 is equal to 250. So 160 plus 90 plus 85, 160 plus 90 plus 85 minus plus common. What is the common? 20 plus 20 minus these two. What is this? 45 minus 35. 45 minus 35 minus, so C N of C intersection M. That's it. Simplify. So 250 is equal to, what is this equal to? So 160 plus 90, then this is 85. 85 plus 20 is 105 minus 45 minus 35 is minus 80 minus N of C intersection M. Okay. Now this is equal to 250 is equal to 160 plus 90 plus 105 minus 80 is 25 minus N of C intersection M. So 250 is equal to 160 plus 90. 160 plus 90 is equal to 250. 250 plus 25 is 275. 275 minus N of C intersection M. So therefore, N of C intersection M is equal to 275 minus 250, that's equal to 25. So therefore, number of people will take only coffee and milk is 25. 25 will take both coffee and milk. That's it. This is how we are going to solve. Okay. Hope you followed. Very simple for 5 marks. It's a 5 marks question and very simple problem. Okay. So the same problem can be represented in a Venn diagram. So number of people in a group, how many people are there? 250. That is N of C union T union M is 250. First write down the common. What is the common? The people who will take all coffee, tea and milk is 20. So the number of people who will take coffee, tea and milk is 20. The number of people who will take coffee, tea and milk is 20. So this is the 20. Right. Then let us write down the common. So what is the common? Number of people who will take coffee and tea is 45. So in 45 already common are 20, that's equal to 25. So the number of people who will take coffee and tea is 25 plus 20 is 45. Similarly, let us come to the next one. That is number of people will take tea and milk. Tea and milk. The number of people will take tea and milk is 35. So already we have 35 tea and milk. Tea and milk. This is tea and milk. The number of people will take tea and milk is 35. Number of people will take both tea and milk is 35. Already 20 is common. 35 minus 20 is equal to 15. Similarly, then what is required to find is the number of people who are going to take coffee and milk. Coffee and milk, that is to be determined. Now, therefore, the number of people will take coffee now. The number of people will take coffee is 160. 160. Here, already we have 160 minus this 25 plus 20 plus 5. That's nothing but 25 plus 20 plus 5 is 50. So 160 minus 50 is 110. And number of people will take tea. is T is 90. Here 90 minus, already we have 25 plus 15 plus 20. 25 plus 15 is 40. 40, 50, 60. 90 minus 60, that is equal to 30. And M, only milk, the number of people who will take milk is 85. Already we have 85 minus this 20 plus 5 plus 15. 20 plus 5 is 25 plus 15 is 40. That's equal to 45. This is 40. So therefore the number of people who will take only coffee and milk is 25. So coffee and milk, the number of people who will take only coffee and milk is 20 plus 5 is equal to 25. That's it. Okay. This is how. So 20 plus 5, coffee and milk. This will give the value 25. This is how we are going to represent in a Venn diagram. Hope you followed. Now let us come to the next problem. In a class of 150 students, it was found that 95 like burger and 79 like pizza. Assuming every student like at least one of the above, find the number of students who like both burger and pizza. Show the result through a Venn diagram. We have to represent it in a Venn diagram. That's it. In a class, how many students are there? So in a class, n of u is equal to 150. So it was found that 95 like burgers. Number of students who like burger, let us represent as B as 95. And 79 like pizza. Let us represent pizza as P. That's equal to 79. Now, find the number of students who like both burger and pizza. So, n of what is required to find is B intersection P is to be determined. That's all. This is given. Okay. Now, very simple problem. N of U, number of students. So, in a class of 150 students means all the number of students who likes burger and pizza is 150. That is given. So, now using this, find out the formula. What is the formula we have? N of B union P is equal to N of B plus N of P minus N of B intersection P. That's all. See, what is the formula? N of B union P, A union B is equal to N of A plus N of B minus N of A intersection B. N of B union P plus N of B plus N of P minus N of B intersection P. Now, what we have here, 150 is equal to 95 plus 79 minus N of B intersection P. So, this is 150 is equal to, add this 79 plus 95, 9 plus 5 is 4, again 4, 14, 1 carry, 10, 174. 174 minus N of B intersection P. Now, therefore, N of B intersection P is equal to 174 minus 150. That's equal to 24. So, therefore, the number of students who will take burger and pizza both are 24. That's it. Okay. That's the answer. Now, let us represent this in a Venn diagram. The number of students, N of U is equal to 150. That is, number of students who will take burger and pizza is 150. And number of students who will take only burger. Burger is 95 and pizza is 79. 95. Number of students who will take pizza is 79. Number of students who will take both burger and the pizza is the question mark. Now, here already we got number of students U is equal to 150, that is B union P is equal to 150. So, number of students who will take B is burger and P is the pizza. So, the number of students will take both is 24. So, 24 students will take both burger as well as pizza. So, number of students will take only the burger is 95 minus 24. 95 minus 24 is 71. And the number of students who will take pizza is 79 minus this 24 common, that's equal to 55. So, this is how we are going to represent. So, this is nothing but the number of students who will take burger and pizza. That's all. This is the representation of the result in a Venn diagram. So, number of students who will take both is 24 and therefore 71 plus 24 is 95, 24 plus 55 is 79. That's it. Okay. Now, let us come to your next problem. Same type. Out of 85 students of a class, first PUC, who took up a combination test in English and Hindi. So, if 63 students pass in both, 12 failed in English and 4 failed only in English. Use Venn diagram to find how many failed in Hindi, passed in English, passed in Hindi. Okay. Now, let us come to the given problem. So, out of 85 students of a class first PUC A section who took up a combination test in English and Hindi. So, how many students are there? Given N of U is equal to 85. That means number of students who will take a test in English and Hindi. E union H is equal to 85. This is the first condition given. If 63 students passed in both, so number of students E intersection H is equal to 63. So 63 students passed in both. 12 failed in English and 4 failed only in English. Now number of students, so 12 failed in English. So therefore N of P is equal to, so N of P is equal to, how many are there? 25 minus 12, that's equal to 73. N of P is equal to 73. Okay. Now N of H, now let us find out N of H, number of students in who passed in Hindi. N of H is equal to N of E union H plus N of E intersection H minus N of E, number of students who passed in English. Now that's equal to N of E intersection H, E union H is 85 plus this is 63 minus 73. What is this equal to? This is 63 as it is. 85 minus 73. 85 minus 73 is equal to 12. So that's equal to 5. 75. N of H is equal to 75. So therefore N of H is equal to 75. N of H is equal to 75. So N of H is equal to 75. That means therefore the number of students who passed in English, therefore number of students passed in English is equal to 75. Okay. So out of 85 students are there. Therefore the number of students who failed in Hindi. So now let us take the number of students who failed in Hindi only. Now therefore number of students who failed in Hindi is, how many students are there? So number of students are 85. 85 minus 75, that's equal to 10. So the number of students who failed in Hindi is 10. So let us represent here. Now next, see here, 12 failed in English and 4 failed only in Hindi. Therefore the number of students who failed in English and Hindi is, therefore number of students who failed in Hindi and English will be 12 minus 4, that's equal to 8. So already what is given? 12 failed in English and 4 failed in Hindi. 12 minus 4 is nothing but number of students who failed in Hindi and English, that's equal to 12 minus 4 is 8. Okay. So that is what the number of students who failed in both is 12 minus 4 is 8. Okay. So therefore the number of students who failed in Hindi only, the number of students who failed in Hindi, number of students failed only in Hindi is equal to, so 10 plus 8, that's equal to 18 students who failed only in Hindi. Okay. So number of students who passed in Hindi, therefore number of students who passed in Hindi is equal to this total. What is the total? 85 minus 18, that's it. 85 minus 18. 85 minus 18. So what is 85 minus 18? That's equal to 67. That's it. Okay. So here, therefore this can be represented in a Venn diagram. So only who failed in Hindi, English is 4. Yes, English as well as in Hindi. So therefore this can be represented in a Venn diagram. Number of students who failed only in both English and Hindi is 8. Number of students who failed in Hindi is 10 and the number of students who failed in English is 4. So totally this is how we are going to represent them in a Venn diagram. That's it. Okay. Number of students failed in Hindi is 10 and the number of students who failed in both Hindi and English will be 8, and the number of students who failed only in English, the number of students who failed only in English, that is already given, that's equal to only in English failed only in English is 4. So that is nothing but 4. So therefore, this in Venn diagram, the number of students who failed in both Hindi and English is 8, number of students who failed in Hindi is 10, and the number of students who failed in English alone is 4. That's it. Okay. Now let us come to the next problem. In a certain college with 500 students, 300 take milk and 250 take tea. Find how many take milk only, tea only, both milk and tea. So what is given here? In a student, n of u is equal to 500. That means number of students who will take milk and tea is 500, and 300 take milk. Number of students who will take milk is 300. Number of students who will take tea is 250. And find how many 300 take milk and 250 take tea. Find how many take milk only and tea only, both milk and tea. Okay. Now let us find out, first find out n of m intersection t first. Now what we know from this, what is given? So here, since n of m union t is equal to n of m plus n of t minus n of m intersection t. Substitute the values. What are given? M union t is 500 is equal to 300 plus 250, 300 plus 250 minus m of m intersection t. Okay. Now minus n of m intersection t. M intersection t is to be determined. Now, so this is, transfer this n of m intersection t is equal to 300 plus 250 is 550 minus 500, that's equal to 50. N of m intersection t is equal to 50. So 50 students will take both milk and tea. Okay. Now, so what is required to find? Milk only, tea only, both milk and tea is 50 we have taken. We already got, this is 50. Now what is to find is milk and tea alone. Okay. That is n of m milk only, not tea, m minus t. All the elements which are in A but not in T, that is difference between m and t is nothing but m minus t. The number of students who will take only milk but not tea is n of m minus t. That's equal to, you know the formula, this is n of m minus n of m intersection t. That's it. Okay. Substitute and get the value. So that is nothing but n of m is 300 minus 50, that's equal to 250. 250. So number of students who will take only milk but not tea is 250. Second one. What is the second one? Number of students who will take only tea. N of t minus m. T minus m. Okay. Same. N of t minus m is n of t minus n of t intersection m. So what is n of t? N of t is equal to 250 minus intersection is 50. That's equal to 200. That's it. Okay. So the number of students who will take only milk but not tea is 250. Number of students who will take tea but not milk is 200. And both is 50. That's it. Okay. So that's all regarding this problem. Now let us come to the last problem in this concept. So in a class of 150 students, each student is required to take at least one of the two subjects, namely biology and economics. If 75 students have taken biology and 25 have taken both biology and economics, how many have taken economics? Show the result in a Venn diagram. Very simple problem. Let us write in a class n of u is equal to 150. That is, in a class of 150 students, each student is required to take at least one of the two subjects. So what are the two subjects? Biology and economy. Biology and B union E is equal to 150. So here 75 students have taken biology. Number of students who have taken biology is 75. 25 have taken both biology and economics. Both biology and economics is 25. How many have taken economics? N of E is equal to intersection. show the result in a Venn diagram. That's all. This is the given concept. Okay. So n of B union E is 150, n of B is equal to 75, n of B intersection E is 25. What is required to find? So you know the formula, n of B union E is equal to n of B plus n of E minus n of B intersection E. Now, just what is required to find is n of E. N of E is to be determined. So, write down the values. N of B union is 150 is equal to number of students who took biology is 50 plus n of E we don't know minus n of B intersection F is 25. So, that is 150 is equal to n of E plus 75 minus 25 is 50. So, therefore, n of E is equal to 150 minus 50. N of E is equal to 100. So, number of students who will take economics is 100 students will take economics. Okay. Now, how to represent this? The number of students are 150, in which common the number of students will take both economics and biology is 25. So, the number of students who will take economics and biology is 25. Number of students who will take biology is 75. So, 75 students will take biology. Already 25 are common. 75 minus 25 is equal to 50. Number of n of B is 75 minus 25 is 50. Now, E number of students who will take economy is 100. Number of students who will take economics is 100. So, 100 minus already 25 is common, that's equal to 75. So, number of students who will take both economics and biology is 25. Number of students who will have biology as 75, already we have 25 common. 75 minus 25 is 50. And number of students who will take economics is 100, already 25 is common. 100 minus 25 is 75. So, this is how we are going to represent in an Venn diagram. So, this is the common number of students who will take biology and economics as 25, and this is number of students who will take economics is 75 plus 25 and biology is 25 plus 50, that's equal to 75. That's it. This is how we are going to represent it in Venn diagram. So, in general, the number of students will take economics is 100 only. That's it. How many will take economics means 100 students will take economics. To 75 plus 25 is 100. So, this is how we are going to solve the problems, practical applications of sets. So, that's all regarding today's session. Let us meet with the different concept in the next class. Thank you very much.